Welcome, everyone. It's really good to have you here. I'm who's speaking now is I'm Ingrid of Sandeberg, and I'm the Vice Chair of Stockholm AI. As you can see, we have a small agenda up to the left on the slide. It's indicative, but just to give you an idea of what we're going to go through today, I'll hold a brief intro. Then our first speaker will take over. We'll have a short break around 20 to 7, and then Galina will speak at 5 to 7. Then we'll have some Q&A and some wrap up. So the only timing which is probably strict is that Galina will start her speech at 18:55. So if you take a break, be back by then. So just briefly about Stockholm AI and who we are. So Stockholm AI is a non-profit organization. We were founded in 2014-15, but we were formalized in 2017, and we want to act as a platform for exchanging knowledge between experts in different fields related to AI. We're dedicated to establishing Stockholm as a global player within AI and machine learning. And we want to be the main hub for the AI and machine learning community in Stockholm. So it's a very technical community in general. To do this, we have our sponsors that help us, and we're already over 3,000 members, so we're growing rapidly. But basically, Stockholm AI, the community revolves around event series in different formats. And traditionally, these have been ranging from technical meetups to very, very technical study groups, reading groups, and workshops, until now, that is. And so this event series, we want to complement our current focus by organizing events that cater to people that are interested in AI, but maybe comes from a business perspective. So we'll be discussing AI, focusing on real life examples, case studies, etc., but using a language which is slightly less technical, but still referring back to the technical fundamentals, because we believe that to be able to discuss opportunities, limits, and challenges with AI, there are some basic concepts that you actually need to understand on a higher level. So this event, as we wrote on Eventbrite, will be focused on an overall introduction to AI, some basic concepts, and it's more like an overview. And then we'll have subsequent events which are focused on industry verticals. So you'll have specific use cases and panel debates from different sectors like mining or gaming or media or music or telecom, etc. But this event will be the first one and give you an overview. And we'll also record this event and we'll be able to post it online afterwards. So, yeah. And these are our speakers. Oliver Turnbull works as a management consulting, but with a technical focus and he works a lot with AI implementation, machine learning, etc. And he has a background in physics and IT on a more general. Whereas Galina Shubina has also an extensive background in artificial intelligence in general, having spent over a decade at Google and built a lot of data streams and strategies. And they'll be able to introduce themselves as well shortly. But first, I would love to learn more about you. So if you go to Slido, you can either use this QR code or you go to slido.com and enter the event poll, the event code, and choose polls. You'll be able to answer a really short poll. It's like 4 or 5 questions, but that really helps us to to know who we're talking to. Just to give a little bit of a contextualizing backdrop before we let the speakers onto the floor. As I said, we'll not be using a lot of frameworks and stuff, but this one I think is interesting, and I think we'll go back to that and refer back to it throughout most of the events in this event series. Basically, artificial intelligence, as we will shortly go through, is based on clever use and analysis of data. So there is no magic or cognition involved. And this framework is useful to understand the processes involved in doing AI. And you can't really skip any of them. You have to collect data. You have to move it and store it reliably. You have to explore and transform it, aggregate it, and label it. And we'll go through what labeling is in a short while before you can do learning and optimization. And AI is basically just the top of this iceberg. So bear that in mind. You might even want to maybe make a screen dump of this and go back to it as we're talking about it. But so this event series will cover more than just fancy algorithms, but also what you actually need to do to make AI work, as well as what you need to understand to be able to grasp its opportunities and its limits. But don't worry, important as it may be to keep this in mind, we won't focus too much on any framework, but on how AI works and how it can be used in organizations, which our speakers are professionals at. So with that, I will leave the virtual floor to the first of them, which is Oliver Turnbull.
Thank you very much, Ingrid. It's interestingly, already a piece of AI is coming to action because I'm getting a meeting alert saying you cannot start your video because the host has stopped it. So I think there's a little bit of AI at your end, looking for faces which are attractive enough to be put on a international webinar. So I can't start my video right now, but never mind, I'll carry on anyway. And if I get permission to start my video, I will. So good evening, everybody, and thank you very much for allowing an international speaker. I'm from the UK, as you might detect by my accent, and hopefully I've got control of the slides, which means if I click, then they might go forward, but it doesn't seem to be working as yet. So when the first slide comes up, it's an experiment that I've done in the last 48 hours or so, which is to try and put my CV on a PowerPoint to make it a little bit more interesting. So eventually the slide will come up, and I suppose this is to test me to see if I can entertain people without using any visual props. So this is me, and I've gone again because I pressed the button twice, and clearly it's just gone through into the next slide. So I've pressed it once back, and hopefully this will stabilize on my visual CV. So just quickly, my name is Oliver Turnbull. I come from Yorkshire in the north of England. I have a degree in physics, 32 years in IT, so that you can calculate how old I am, 25 years consultant, 7 years a digital consultant, and 3 or so years in artificial intelligence. And my journey has been from a factory floor in Halifax, and the top left shows a tape reel, which are the things I used to work with. So I was an operator on computers. They then gave me my own computer, and I became a programmer. They then gave me a telephone, and I was on the help desk because I like talking to people. And I then got my own PC in around about 1990, and I finally discovered the internet a couple of years after that and got my own laptop, an IBM ThinkPad, in about 93, and they sent me off with my laptop to sell snake oil or software salesmen being the worst people on the planet. So I wasn't that for very long before I moved into consultancy. And the 3 circles represent my life in consultancy. So I started off managing successful programs, which is a government standard in the UK. And then I moved on to be what I rather grandly call myself, a digital strategist, which is a center circle. Eventually, I met a lovely guy called Andreas a couple of years ago, who was a business analyst within the company I was working for, ADL. And he started to tell me about artificial intelligence. And it rekindled my love of computers numbers, because I learned, as hopefully I'll move on to you, the fact that actually artificial intelligence at the end of the day is very much to do with maths, fairly simple maths, but just lots of it. And so I fell in love with artificial intelligence and, of course, what it could do in the context of a business strategy and my work learning with clients who want to make use of their data. In the bottom right-hand corner, I've just put a few things I quite like. I like my children, the boy and the girl, they're quite nice. I also like my wife. I just realized I haven't put her in there. I like my guitar, which I just bought today. My motorcycle is lovely. I like my Microsoft Surface. I run a podcast called Why the Long Face. I come from Yorkshire and I support Tottenham Hotspur, which is a football team, for those people who don't know, who got to the Champions League final last year. I went there and we lost to a probably better football team called Liverpool. I'm just filling in now because I'm getting used to the gap between me pressing the button and my slides coming up. So what is artificial intelligence? Well, it's a very broad term and there are very different definitions from it, but it's basically mimicking the action of a brain as far as I'm concerned. And so that is fairly broad. So we narrow it down to machine learning. And machine learning is really what I'll be talking about today. And the machine is obviously usually a computer. And what machine learning really is getting a computer to solve a problem without actually programming it. So the degree of learning really within a computer is derived from mashing a load of data through it. And we'll see how that works in a minute at a reasonably high level, because this is all about my journey from being an operator to being a consultant to being someone who really enjoys the art of artificial intelligence and using it to make value for my clients. So machine learning is using a computer to get a better answer than you would if you programmed it by pumping a load of data through it. Neural networks are a particular type of machine learning, and they are structured in the way the brain is structured. And I'll touch on that very briefly because this is rather an overview, as Ingrid pointed out. Deep learning goes even deeper than that, and that's very complicated, multi-layer neural networks. It's neural networks linked to each other. It's various machines linked to each other, and that solves the really complex, cool problems that we don't really touch on in business that much. Data science basically covers all those things. So we will probably focus, we'll definitely focus, because I've created the slides, on machine learning, which is the bit that says, put a load of data through a computer and the answer will be refined over time, if you give it enough time and if you give it enough data. So when Andreas, this wonderful, very junior, very young data science graduate who's now earning a lot of money in a bank, started to teach me about machine learning and what it meant, he said it's really quite simple. There are two types, or three types really. One is supervised and one is unsupervised. So this is one of the concepts that as soon as I grasped it, I thought, hang on a minute, this stuff really isn't as complicated or as mystical as I thought. And you really can get under the skin of it and understand at a conceptual level how it works without having a degree in maths and without being a complete data science nerd. And once you start understanding how it works, you can really apply it to business problems. And that's when it gets very exciting. So if you look at a table here, imagine you're looking at houses and what their features are. So houses have features such as area, age, and all sorts of other features such as how close they are to public transport, how close they are to schools, how close they are to parks, etc., etc., etc. So you may know a lot of things about input one, which is the first house, including the price, 300,000 euros, for example. So you can imagine a data table like this very easily, which looks at several houses, several hundred houses, several thousand houses, its features, and what it costs. But what you want to know is when you put another data item in, where you know all the features, the area, the age, the proximity to schools, the proximity to transport, how much is that going to cost? So what you want to do is put loads of data rows in where you know the answer, what the price is going to be, to help you get the answer for where you don't know what the output predictor is. So in mathematical terms, you want to add a function hypothesis against the data set X to get the output Y. So if you remember your school, the top left, you draw a graph. So you draw a graph of house price versus house size, and you can make a prediction based on those discrete values that you know. So you can draw a line up the x-axis and get the house price from the y-axis. What artificial intelligence does is create a graph in its memory of many different dimensions and makes a similar prediction. And anyone who's done maths at 16 level and at 18 level can remember creating a mathematical function which best fits the dots. And effectively, where you've got labeled data, which is discrete data, a particular number, then that will allow you to classify an object. So if the label is continuous, in other words, like a house price, so it can be any number from 0 to 1,000,000, then that's a regression problem. So that gives you an answer on a multidimensional graph, which says for this set of features associated with the house, this is probably the price. Where it's a discrete label, in other words, the item is one of a discrete number of things, then it's a classification problem. So when you want to predict the price of something, for example, you tend to use regression. Where you want to predict what something is, you tend to use classification. So the graph at the bottom right says, if I take the height and weight of a load of different human beings, they tend to form in two groups. One, they're slightly higher and slightly weightier, and they're one group. And the other group is slightly less weighty and slightly less heighty. And over millions and millions and millions of observations, you find that when you put a new data point in, like the green point, it tells us someone who's quite high and quite heavy, they are probably a male. And that's a classification problem. And of course, remember, you will have many, many, many different features within a data set for the computer to determine what class the observation falls in. So if you're trying to detect fraud, there are hundreds of things you might know about a particular transaction, where it's come from, where it's going, the amount, how regular it is, and a whole host of other features on that transaction. And that's where the computer, when it compares it to millions and millions of other ones, can say fraudulent or non-fraudulent. And you can set the parameters so that you are more and more sensitive or less sensitive based on how sensitive you want the machine to be. So that's supervised learning, where you know the answer for hundreds of thousands of other situations, and you want to know the answer for the next situation. But what about unsupervised learning, where you've got a whole load of things and you don't know what they are? So the example here is you've got a load of objects. There's a house in there, there's a factory in there, there's what looks like a temple. We know they're all buildings, but they're all very different. So the little cuddly animated chap there is saying, what is all these things? And so what the brain can do there with unsupervised, it can say, well, those things with columns, they look pretty similar. And those things that are tall with windows, they look pretty similar. And that thing with a big chimney looks different from everything else I've seen. And those things with sloping roofs that only have 1 or 2 stories, they seem to be similar as well. And the big ones seem to be similar as well. So what the computer can do in the situation of unsupervised learning is look at a load of stuff and work out what's common about those things within the group. So for example, if you measured the height and weight of loads of people, you'd see that there 2 clusters might emerge. And one might be man, one might be woman, if you're observing humans, or one might be a different breed of dog, if you're observing dogs. But the cool stuff comes with what's called reinforcement learning. And reinforcement learning is essentially the third type of machine learning, or the third major type. And this is about playing a game. And this is where it becomes really interesting. And this is where I got really, really interested. So you have a thing. So that thing is a robot because it exists within the computer, but it's the actor in the system. You then have a world, which is the parameters that affect that system. And if the actor was a autonomous car, then the world is the roads. So it becomes very, very confusing, very complex. If that person is a player in the game of chess, then the world just pieces on it. And that is as far as the world extends. So the actor interacts with its world, and you give a set of parameters that shape the world, and you put the world in a state. So if the world is a chessboard, the state is 2 ranks of pieces for each player, 8 pawns, 2 bishops, a king, a queen, etc. And they're all on those ranks at the beginning of the board. And those are the environmental parameters that are the initial state of the game of chess. You then allow the actor to take action, which generally is moving a pawn forward or moving a knight forward in a game of chess. But the universe has a set of rules. And in a game of chess, we know what the rules are. The rules are pawns can move 1 place or 2 places, and bishops can move diagonally, but they can't jump over other pieces, etc. In an autonomous car situation, of course, the rules are far more complex. In other words, you can't hit things and you must stay within a certain amount of distance between things that look like this, etc. It's far more complex. And the other thing within the system is a reward system. So the robot will get a reward if it does a certain thing. So a reward for taking another opponent's piece will be a certain amount. A reward for taking a high value piece, like a rook, will be higher, taking the queen, higher still. And if you put the king of the opposing player in a position that it can't get out of, that's the highest reward of all. And what reinforcement learning does, and this is crucial, it plays the game thousands, hundreds of thousands, millions of times. And so in the game of chess, the reason computers have got so good at playing chess is that they play each other millions and millions of times. So they have effectively done a trial and error over billions of different samples to the point where they have played more chess games than any other human in the history of time, which is why they're good at chess. So the difference between an AI chess machine of these days and Deep Blue in the early 90s that did quite a good number on Kasparov, I think it was, is that we haven't taught them how to play chess in the sense of, if this happens, do this. We've allowed them to, through reinforcement learning, learn chess themselves from being completely terrible at chess, because they'll die straight away, to having played more chess games than any other human who's ever lived, which is why they're better than grandmasters, because not only do they have a bigger back catalogue of knowledge, they also never make mistakes. So a very simple reinforcement learning is this robot here, and he's been told that the door must be closed. Okay, so what the robot does is he or she learns that when the door is not in a state of closed, it must do whatever it can to make sure that the state of that door is a closed door, and therefore it learns to use the handle to push that door. So this is what reinforcement learning is, and it's very powerful, and it's very sexy, and it's very clever. And it's what everybody talks about when they think of artificial learning. But the thing to remember about reinforcement learning is you don't necessarily need a lot of data, you just need an environment for the actor to live in. Then it will play the game until it works out how to do the best actions within that system to get the best result. And of course, you can set the rewards yourself. The other two types, remember, are supervised and unsupervised. So supervised, where you have a lot of data, and you know the answer you're looking for, and you can either do a regression or a classification. In other words, predict what the next answer is going to be, or classify what the next answer is going to be. And then unsupervised learning, which is very good when you want to cluster. For example, if you're clustering customer behavior, you know a lot of things about the way that your customers behave, but you can't necessarily cluster them without a machine to do that. Things that predict what's going to happen in time are called time series regressors, and they're very interesting as well. So it's a regression type machine, but the x-axis, if you like, is not the square footage of a house, but it's time. So it takes observations, many thousands over time, and then extends the x-axis to make predictions. For example, trying to predict the stock market, impossible, by the way, or trying to predict how my product is going to sell in Scotland or in Sweden, etc., etc. And those are the kind of problems that these are used in. I'll touch on very quickly, because I haven't got much time, on neural networks, but neural networks can apply to all these techniques. Okay, so you can have a neural network which can help you with supervised learning, with unsupervised learning, and certainly with reinforcement learning as well. And the interesting thing about neural networks is they work like our brain. So that's a very simplified version of what a neuron looks like within our brain. But actually, to do all these sexy things like facial recognition, pattern recognition, speech recognition, and all these things that we find all the time, and robotics, etc., all rely on the neural network, but within a computer. And what all a neural network is, and this is probably all I have time to tell you, is a number within a computer, and then some inputs into that cell. And that's it. That is effectively how a neural network works. It has many neurons inputting into a particular neuron, and then that neuron inputs into a neuron further down the chain. And these sigmoid, tanh, and ReLU functions, the activation functions, are just mathematics within the neural network to make sure that when you have several inputs into a neuron, that value doesn't explode into a meaningless value. So the other rule within a neural network is every value must be between 0 and 1, and it gives you a probability. And these neurons, just like they are in the brain, are organized in layers. So you have your input layer, which is the question, the hidden layers, which work out the maths, and then the output layer, which gives you the answer. And this is what a neural network is. And that was an absolute revelation to me as to how these things worked and how simple they were at the very basic level. So the interesting thing is every neuron links to every other neuron in the next layer. What does that mean? So that means that the weightings, in other words, the importance of the previous layer, are dedicated by maths. In other words, the value between 0 and 1 held within that weighting. And what happens in a neural network is, and this looks like complicated maths, but actually it's just a series of numbers, is that as the data flows through, the back propagation which happens checks how close to the actual answer the neural network is predicting. So it self-balances as more data is put through it. And that is basically the magic of a neural network. A number of numbers which feed through from one layer to the next, activating neurons as they go. And in this multi-class classification, you've got an input, which is a house, and an output, which is either the neuron which says house firing, or the neuron that says office building firing, or the neuron that says factory firing. Factory firing. And of course, in this case, the house neuron fires because it's a house. So the trick with neural networks is turning that photograph into something that's machine readable. And the other thing with neural networks is having lots and lots of data. In a sense, what it's doing is magic. It's very, very hard to describe. But what it's actually doing is encoding within the weightings and biases within the network the answer to the question, if I put this input in, what output should I get? If I put a photograph of a cat in my Google Photos, I should get the answer cat out at the end. If I put a picture of a pigeon, I should get pigeon at the end. If I put a racing car in, I should get racing car at the end. And it's almost magic. And the disadvantage is that we don't really know what goes on under the scenes. All we know is that as the machine tunes itself, it learns more and more about what a cat looks like, or it learns more and more about the properties of this thing that you're inputting so that it can classify it as something that you could make useful in business potentially. For example, the social media example is Instagram, okay? So as you might imagine, Instagram has many, many different transactions going through the whole time, many different types of picture, many different types of commentary and comment. And what social media, Instagram and Facebook are doing as well, is trying to understand from which type of communication is a bullying type of communication from previous interactions, what type of interaction is, what characteristics of that interaction make it into a bullying one. Again, we don't know how it works, but we do know that these million records represent a bad transaction between two people where one is bullying the other. And so that we can predict the next transaction might be similarly bullying, and therefore put some alerts in to do some intervention at whatever level to make sure that doesn't happen. The smart home again is using predictive analytics to understand your preferences, your personal preferences regarding the temperature you like in the house, the high lighting you like in the house, bearing in mind the environmental and climatic conditions around your house and within your house. Fraud prevention, I mentioned before, is looking for a classification of a set of events in a massive data set which indicates fraud. So it's a classifier in a sense. So it's a supervised learning classifier in that it knows that this set of transactions were fraudulent. It knows that this set of transactions was not fraudulent. It can then say that this new, fresh set of transactions, which I've never seen before, has a high probability of fraud or a low probability of fraud, etc., etc., etc. Google Maps is a sort of reinforcement algorithm because it knows where you're trying to get to. It knows what cars who are using Google are on the road. It knows other factors such as weather, roadworks. It plays the game really, really fast and gives you the answer. So it's actually playing a game within its mapping system, taking into account how fast you're moving, how fast everyone else is moving, and what other environmental considerations are taken into account. It plays the game instantly and works out, actually, you'd be better coming off the M25 at this junction rather than that junction. And I'm doing a reference which is very UK-centric, so I do apologise. You come off this particular generic road at this junction rather than that junction to get to your destination quicker. So I think I have come to the end. I've slightly overrun, but not by long. Thank you very much for listening. I'll stay on the call. I'm sorry that it was so quick, but I would leave you with sort of a couple of messages. One would be that there is no mystery to AI. It's just a lot of maths. And it's particularly good where you have a lot of data where something's happened in the past and you want to predict what's going to happen in the future based on observations that you're going to happen. It's very good at classifying, so it's very good at being fed loads of data and for it to understand the groupings of that data. And it's very, very good at playing games. So if you have an optimization problem, which says, I've got, this is one that comes from a real world example, in that we were working for a telco company, and they have a number of clients who have to have a certain amount of bandwidth at a certain amount of time, and we've got a certain amount of assets, some of which are very expensive, such as leased lines, and some of which are very cheap, such as wire that we own ourselves. So is there any way of optimizing the use of our assets to satisfy the needs of our customers, which is a very numeric thing, bandwidth, of course, which is a number of megabits per second? The answer, of course, is, or else I wouldn't be mentioning it, yes, and that's done by reinforcement learning. In other words, you put the rules of the game in. We have this many nodes, this much wire, this many clients, this much bandwidth available in these particular regions, and this much bandwidth that we must give to our clients. Computer, which is the best way of organizing our assets to deliver the best service at the cheapest price? And that was something that we did commercially for a telco in the UK, and that worked brilliantly. So it's that kind of problem you've got to look for in business. I want to predict the future, I want to group things, and I want to optimize things. And those are the three problem types that we find when we're consulting for our clients are the ones that lend themselves best to an AI answer. Because as you will know, AI is a bit of a buzzword, and everybody thinks it's the answer to everything. It definitely is not, but it's here to stay, and it's extremely powerful, and it's very cool and interesting. Thanks for listening. I'll stick around. I'm very much looking forward to the next speaker, and it's been a pleasure to spend a bit of time with you.
Thank you so much, Oliver. That's super helpful. Always a joy hearing you explaining the bits and pieces and components of AI. Great that we will stay on the call. We will have a Q&A session after Galina's talk as well. So everyone fire up your questions in the Slido app or on Slido, and Oliver will be able to reply later. I should also say that, as you said, Oliver, we're going through this a bit quickly now, but as I mentioned, this presentation or this webinar will be available online afterwards, so we'll record it. We'll now have a short break. It's going to be 10 minutes approximately. So please make sure to be back at 6:55 when we will have Galina talking about bringing data analytics and AI to your organization. See you in a bit. And it's 5 to 7. Welcome back, everyone. I hope you had ample of time to get a cup of coffee and maybe technical break before we let Galina on. Welcome.
Hey everyone. So, and here I am, and you guys can enable my video also if you would like. It says here that the host has disabled the video, and then I would like to take over the presentation. So can you see me? And can you see the presentation, I guess is the question. Hello, hello, hello.
Yes, we can.
Okay, sounds good.
I don't think that we disabled the video. I'm not sure why it's not working, but we can see your screen at least.
Ah, that sounds good. So I'm going to, despite having the thing, I'm going to struggle, I'm sure, and have some kind of a issue with the, give me a second. Yes. Okay, technical difficulties. You know, we're doing it wrong if we can't manage to have a few of those. Yeah, so my name is Galina Shubina, and I guess as Oliver has done it, I can do a short presentation also of who I am. So despite my name, I'm mostly American, even though I was born in this weird country called Soviet Union. And so I lived most of my life in the United States, and I moved to Sweden about 12 years ago. And my background, whereas Oliver's is in physics, my background is actually in computer science and mathematics. I also had a misfortune of entering grad school in order to get a PhD, which I never finished, even though I spent 6.5 years there. But after I quit, I decided that I will get a job. And the job I got was with this funny company called Google. And the rest, as they say, is history, because as it happened, you know, I was at Google. I started doing data science at Google before data science has a name. And it was 2004 and very interesting times. And I think I would say that probably much of my experience came from that. So after 10 years of being a data scientist, software engineer, data engineer, and whatever you name it, I left. And since then, for the last 6 years, I've basically either building my own data and machine learning teams, or I've been helping other people to do the same while doing consulting. And so right now, I have a 2-person company together with my partner, Valerie. And we've helped people figure out what to do with data and machine learning and AI, because it's a slightly non-trivial question. And people start from the strangest corners, and that's exactly what I'm going to speak about today. So Gradient Descent is the name of my company, and if you come from a technical end, you would know what that means, and if you come from another end, you probably don't. But let's just say that underneath, most of the machine learning algorithms use a special algorithm called gradient descent in order to find the most optimal solution, in order to find the most optimal whether it's neural network or something else, that whatever it is that they need to do in order to come up with a great answer. And as part of our work, we have a couple of collaboration. I think the most interesting one right now is a responsible AI collaboration with Virginia Dignum and a bunch more people. And the other one, just looking into future work and innovation and trying to figure out exactly what it is that is going to happen. And that's also related to the fact that with AI, we kind of need to figure out what it is that we are going to do. Anyway, enough about us. I generally, these days, people have seen a lot of different applications of AI, I would say, and I'm not going to speak much about it, but I like to kind of think about the fact that it's good to remember that a lot of applications of AI we have are rather boring, and we use it daily. And a common one would be Google search, that has multiple recommendations algorithms that fire every time you enter something into the search box. And it also has a bit of personalization here, and it has a little icon over here that allows you to speak in your query which also uses machine learning in order to be able to interpret words. And then it uses all of these things that you type and do. It basically improves Google search, is being used to improve Google search after that. And that's kind of a boring daily thing. And of course, the amazing thing right now, even though these days I guess we are talking so much about about autonomous cars, that they're starting to feel boring, but I'm still waiting for this. It's just amazing to think that I will probably live to see some kind of a world where autonomous cars are going to be normal. But all in all, a lot of the companies, a lot of the work that I came by doing consulting was, I would get calls from people, and it would kind of go, hey, you know, we have some data, and there's this machine learning thing. That's what it used to be. The last 2 years, it's, oh, there's this AI thing. Everything is getting renamed in our business on a yearly basis, and we're just trying to figure out what's worthwhile to do over here. And I would say that's a best case situation where they call me before they start on something, because it's getting better now, but it used to be a common story would be that the companies kind of look at things and decide they need to do something with data because data is valuable, and they have a lot of data, and it's great data. I mean, really, all we need to do is find a data scientist or a machine learning person, and it would be ideal if they have a PhD. A lot of the times they would be fresh out of a PhD, and the expectation would be that they would take the great tools and they would apply them to the data, and, you know, essentially some kind of magic would happen. So, and it's nice doing it with the audience, because the audience at that point usually starts laughing because I know how that one goes. Better now probably than 5 years ago. But the end result is almost invariably that it turns out that the very first thing we start doing is looking at the data, and the data is all over the place. And we are lucky if we have any usable data by our terms. And then the tools kind of need to be clutched together a little bit, and one needs to extract that stuff, and kind of one really needs to start, you know, in some other corner. And these projects tend to take, you know, anywhere from 6 to 18 months to get the very first usable data flowing in order to be able to do any kind of applications. It can be a difficult and fraught process, while at the same time the business folks kind of get upset that they're not getting ROI out of the whole thing. So, and this is where it comes in. You know, when people talk about AI, they kind of, a lot of the times people instantly want an application that would be usable for us. And AI is a bit of an iceberg. And as Ingrid mentioned, you know, the data science hierarchy of needs, which was created by this amazing woman called Monica Rogati from Jawbone. So she created this based on her experience, and it really shows that you really need to start collecting the data, and then you need to work and start processing the data, and then ideally you would get a data scientist into the whole process pretty early, because they will actually be able to determine whether the data is useful specifically for machine learning programs. Because as a software engineer, I can tell you that data that you need operationally is a lot of the times not exactly the data that you need for your machine learning stuff. So, and then you kind of start working your way upwards. But you know, this, you look at this, if you look at this diagram, you realize it doesn't really tell you which applications you should develop, or how you should start doing it, or even how you should start selling it to the people who are the budget stakeholders in your organization. And so, and then you start kind of looking at the technologies, and this is a data and AI landscape in 2019. You know, your eyes are probably going sideways and you can no longer read the diagram. And I can tell you that when I started doing these talks, I had the data and AI landscape from 2016, which was still readable on a small screen. And that is no longer the case. And so the important thing really are the stories that we tell with our data, and figuring out how we can tell stories and which stories to tell about your own organization, about your own company, about where AI would exactly be useful. So I know Ingrid said we're not going to use frameworks, but this is actually a framework that we've developed by working with people over the period of 5 years. And it started in a much, much simpler fashion as 4 boxes. And it arrived over here, and we found that it's been really useful in framing the problems that people have and where they could get a value out of their data. And the value may not necessarily start with AI, but the more you use the data, the more you realize that you start applying the algorithms for something that you need, you start using it, you start understanding how your business works better, and then you are able to determine what it is that you need to do next. And so I'm going to go through this a little bit in order to frame these for you. And you will notice, and I will point at it a little bit later also, that the bar for AI on the right is, it increases from top to bottom. because it's actually not so trivial. And as an example, I can tell you that task and process automation, a lot of task and process automation that is being sold and done these days, a fair bit of it is not AI enabled, but then some of it is AI enabled. So you kind of need to do some of it, but which methods you apply, it may depend a little bit. We are moving more and more toward AI methods, but it's not always a clear-cut question, I would say, probably. So where do we start? I have this lovely quote that I saw for the first time, and it's really rang true with me. One of the common fallacies is that data is opposed to intuition, and data is actually a tool for enhancing intuition. And so this is Hilary Mason. We actually went to grad school together. So she was heading up data at a company called Bitly, and then she started working, created her own startup called Fast Forward Labs, and now she's VP of AI research at Cloudera, essentially. So, and why is this important for us to start with? It's because businesses, in order to bring AI to the business, the very first thing they need to do is to become data-driven. So, and people need to be able to show up in the morning and be able to see what's going on and how everything is going, how the business is doing, how many users they have, how much what is happening with the revenue, maybe what's happening with the marketing budget too. Ideally, they should be able to look at all of it at the same time, and it is shocking how rare it is still. So being able to understand what is going on is using data is very, very essential in order to start on this journey. And it tends to be not so complicated to do, and it tends to be a good way to start cleaning the data while creating some kind of ROI for the organization, some kind of visibility also. So as you probably know, in a lot of companies, if you have a CEO, and usually he gets once a month his amazing report, and it takes analysts about 3 days to crunch through Excel spreadsheets, which contain this data. They pull it from a variety of different places, and then it kind of like finally gets munched down into a bunch of PowerPoints. And the situation should really be is that you show up on a daily basis and you can look at the dashboard, and that people in the management or people in the product management can actually look at dashboards where they can do drill downs, whether it is by country or by something else that is relevant to business. It will depend a little bit. And that's really when people will start understanding where should they move, where should they dig more, what they should do. And what do we have next? What about the other people? It turns out that in order to create machine learning applications, among other things, but also one needs to understand the data better. And the way to do it is to democratize the data, to democratize analytics, to make it more easily accessible. So those of you who worked with Google BigQuery, for example, you may have been in a situation where once the data is in a warehouse like this, suddenly there's an explosion of insights and understanding, and kind of like people go, oh, hey, there is this an interesting thing that we can do. And I've seen it twice now at companies, and it's an amazing thing to see. So it tends to be this, in some cases, it can be an expensive project, but it really can become exponential in terms of how useful it is for the business. So democratizing analytics is a very important part of being a data-driven business. And then, of course, there's complex decision support. And it's important to remember that the business is, it's a combination of things. It's a marketing operations, it's infrastructure systems like, your APIs and your backend servers and all kinds of other stuff. You have users and customers who do all kinds of strange things. You have revenue. It can come from ads or subscription, or it can come from sales. And you have some kind of operating budget, and something is happening with that stuff. And the way to think about it is that you have a complex physical system, in a sense, or you can think of it as a physical system, and it interacts in interesting ways. And when things happen in one part of the system, it affects the other parts. And it's very important to be able to, a lot of the times you need a much more complex analysis, statistical analysis, or in some cases, AI style analysis, where you would apply some kind of clustering to your users, for example, in order to understand what is going on there. So it's very important. So if you manage to democratize your analytics, and therefore your analytics department is not spending all its time responding to really simple requests, you can actually dig into the complex decision support. I would probably say the most typical example in that area is questions of user churn. You know, how long your users stay and when you lose them, or users' lifetime value. But if you think of this as a physical system and you put people and you start working on it, you'll find a lot of interesting stuff that will help you really make decisions about the business. So I think this is kind of like people don't do this enough. But anyway, data-driven decision support, that's boring, right? Like that's dashboards and things and data warehouses and all the rest of this crap. The interesting stuff really is product development. And let me be very clear. I mean, a lot of companies, a lot of organizations like government agencies, they don't really have product often as such. But, you know, a lot of companies, more regular businesses do. And here you have kind of a typical representation. This is a really old comic about what product development looks like. How the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented. Oh, there's still clouds over there. The clouds should be gone. What operations installed, how the customer was billed, how it was supported. There's a nice stump over here, and what the customer really needed. And I think it's a good thing to remember, and I'm sure Oliver remembers since he's been in IT for many decades, that this project can take a really long time. They can take 12 to 18 months of time, and then you discover that, hey, I'm sorry, hey, you know, like we didn't quite have the right thing, what's going on over here, and a lot of money is spent. So it's very, very essential in order to do data-informed product development, but I would say any product development, is to have a fast iteration cycle where you go through a cycle where you have ideas, you build something or you prototype them, you develop something quickly, you validate it with your users. Hey, does it look like the right thing approximately, even if it doesn't have all the features? And then ideally you have data from this, whether it's qualitative or quantitative data. And then whatever you learn from it, hopefully you get better ideas, and then you can continue like this. And why is this especially important for the diagram that had AI in this? The reason is because we need to test models. The first models that we create are often not very good or outright bad, but it's important to have a cycle where you can launch the new models all the time and then see what happens with them. And it's important to have kind of a complex thinking around it sometimes. So you can see, well, the new model we launched, for some reason it did something bad to a particular group of users. You know, that means that you need to be able to sometimes look a bit more closely at the data you get out. So not just looking at the headline metrics, if you see what I mean. So, so let's say you have a fast iteration cycle, you go quickly, you start running experiments, and you discover that, well, in order to evaluate the experiments properly, it can take you, you know, from a week to a month for some analysts to maybe look at some Jupyter notebooks or something and be able to tell the product manager and the management that, well, seems to be good, needs more work and stuff like this. So the next step in this is to ideally, especially companies that run a lot of experiments, they usually end up developing an experimentation platform, which tends to increase the amount of experimentation and dramatically improves the quality of more or less everything they do, but also the quality of the machine learning and AI that they produce, actually. An experimentation platform makes it really easy to launch experiments, and then shows you many metrics, basically, when the experiment is run and once the experiment is run, and tends to be a very useful thing. Also, this ensures basically that when you evaluate your machine learning models, you don't make mistakes in your calculations because everything is so standard. So you can see here, like an experimentation platform, it's something that's both useful for AI and for non-AI type of launches. So there's a bit of, you know, you can talk to the business about how it's useful, you know, and it can provide an ROI, and it can really improve your operation also if you have it. And then there's fact-based prioritization, which is actually a simple concept that, once you have data, then you can actually start having less of a hippo, highest paid person in the room kind of conversation, making decisions about stuff. You can actually make decisions which are both based on intuition, but also based on data if you have this. Sometimes if you have an idea, you don't need to argue about it. You can just have a little bit experiment that you run, especially if you have a user product. So all of this is great. And now I've talked to you for about 17 minutes, and we still haven't talked about AI products properly, right? So, and yet AI products are all around us. So all of these people who try to figure out if AI is at all useful for them, they can, they have all of the cell phones on the table, and they have some kind of Alexa device that is probably incorrectly interpreting their conversation, because we haven't quite arrived at good, at good interpretational intelligence. So, and in that area, I think if you are a business, I find that there are two types, two categories that exist. One, where you look internally to how you can improve your business, and one where you look externally for how you can improve your products. And it's very important to separate those two. They're different strategically, and they're different in terms of how to think. And in one case, people are a bit more likely to use third-party AI applications, I would say, although not always. And in another case, they're more likely to develop things because it is in their own domain and they need to have this knowledge in-house. So let's say you're a business and you want to improve the operations with AI, or maybe not with AI, as I said, if you remember that triangle that you saw in the diagram. So the first question to ask is, what do you have that is manual and repetitive? Are you scanning receipts all the time? Can you make this better? Can you basically be able to automatically recognize what is happening on the receipts and have it put into your accounting system? Is there something else that is going on in the customer service that is incredibly time consuming and super annoying, and you would rather have your customer support spend time on complicated questions? So all of this, if it's manual and it's repetitive especially, it tends to be easily automatable at this point. In more complex cases, I would say you might need deep learning for it, but it's a pretty clear-cut case. The next one is more what I would call process optimization. Do you have something that is time-consuming? And if it's time-consuming, then that's a good area also to automate. And the last one is, can it be done better? Because, for example, I know that some gaming companies these days, they use AI in order to automatically pre-generate levels for them so people can start working on them. And sometimes they can do a more interesting, a better job in a sense, to give a start than a person would be able to do in a timely fashion. So that's task and process automation. And my favorite example of this is the fact that Google used DeepMind in order to reduce their cooling bill in the data centers by 40%. That really saves them a lot of money. And of course, over there, I talked about the time, but I didn't talk about the revenue optimization, which is very, very important. And then we have AI features and products. And the three areas where we split it in two is, one is straight up, which AI features and AI products, of course, companies can have. And I will not speak about it because I'm sure you heard plenty about this before. But the important concepts here are the virtuous cycle of AI, which is a concept that Andrew Ng talks about as part of his lending AI company. And the idea is very simple. If you create a product that is based on data, that it uses a lot of data, let's say Google search, the more users it has, the more people search, the more Google understands which links you click onto, the more it can use this to show you more relevant links. So the better the product gets. And when the product gets better, you get more users and more data. And it's a nice virtuous cycle where your things improve. it can also give you a defensible position. So there's a company called Blue River Technologies, which started detecting, putting cameras on the tractors and figuring out where the weeds are in order to spray them with pesticides. And if you spray in a targeted way, turns out that you can use up much less pesticides. So it's a pretty good thing. And as they were the first on the market, they actually ended up with one of the better AI products because they already collected a lot of data. So it's a nice defensible position if you can start first and you can get it. And I'm out of time more or less, but there is a whole interesting world of business models around AI. And, you know, there we would talk about things like learning by doing, you know, which is more or less a virtual cycle of AI. And the fact that if you're not using your data, you're not producing any value, additional value for your company. The network effects, which are interesting, and they can be direct network effects. So the more people adopt a product, you know, the more valuable it becomes. Or there can be indirect network effects. So for example, like if you have an OS with many applications, that would be one. Or you can have, you know, a classic thing where if you have an application where you collect a lot of data already, it may be enough. You do it once and it's really expensive, but after that, basically your product is free for you to produce. All you have to do is sell it. I don't have time to go into it much, but that's sort of my view of it. That's how we tend to look at it and how we tend to suggest to people they work with this. They can start in multiple boxes at the same time, but it's important to remember that you don't always have to use AI in all of those boxes, even though you want most of them, but also that you can start with simple things in order to develop more complicated things later. And as I said, it can be a little bit of an easier sell to the budget holders in many cases. And the last thing I'm going to leave you with is actually we did a small survey and we discovered that 44% of the people think that they have a lot of things in the data-driven business. And about 23% think that they do product development in such a way that it uses data in order to allow you to quickly improve the products. And interestingly enough, the applications for task and process automation, internal ones, were slightly lower than AI in features and products that people have. But there's more work that we can do because it's so interesting to see what people are doing. And it will be even more interesting to see what you people will do in the next few years. And thank you very much. And let me see if I can stop sharing now. And Ingrid, Martha?
Great, thank you so much, Galina.
Thank you, guys.
Super interesting and relevant to hear. I'm just want to make sure. Do you see the Slido now?
Yes, I do.
Awesome. So as I mentioned before, you can ask your questions in Slido. We've got 7 questions up until now. Oliver, are you there as well?
I'm here, yeah.
Excellent. Great. So thanks a lot, you both. I'll just fire away with the question with the most upvotes first. So it's a great keynote. What makes a use case a good candidate for AI? Oliver, could you answer first and then Galina afterwards?
Yes, a good candidate for AI. Now that is a good question, and that is sort of part of my life at the moment, because we're always looking for proper use cases where value is going to be added and not where we're just playing around using a tool for a problem that doesn't exist. So we spend quite a lot of time with our clients unpicking the real nature of the problem from the noise, if you like. So that's always time well spent. Time well spent also wrangling the data, as they call it. In other words, looking at the data they've got, playing with connections, looking for potential answers, playing that back to the user. And those cycles, whilst not traditional when it comes to selling a technology solution, are very useful indeed for making sure that if you're going to fail, you fail quickly. And if the question really isn't answered by AI, then you get to the lack of answer quickly with less investment. So I would say that there's sort of three areas really. There's one will be the problem. Make sure it is a problem that is either an optimization problem, or a predictive problem, or a categorization problem, generally speaking. And Galina has far more expertise in this than I do in terms of what other problems might be appropriate. So start whilst you've got a potential route to solving the problem using one of those techniques is really, really important. Make sure that the problem is specific as well, and that you can express it in terms that the client understands and is very much tuned to the client's context and not too general, I would say. So the problem definition and the nature of the problem is extremely important. The next one comes is data. You won't be surprised to hear, and that's incredibly important. So if it's something that you're using, something like a neural network or some kind of other classifier or optimizer, it's very important to have lots and lots of data. The more data you have training one of these machines, the better outcome you're going to have. And also representative data as well. So not just test data, real world data, because of course the machine only gives predictions that relate to the data that it knows about. And clearly one thing, it sounds obvious, but it's really, really crucial, is that the data is freely available and the data is easy accessible. So many whiteboarding sessions are very, very theoretical. And if we knew this, and we knew that, and we linked it to that, and we sort of mapped to social media to get some sentiment analysis, we could do incredible things. But if you don't have access to good, clean data, which is current, accurate, and can be linked, you're not going to get anywhere. And finally, this is the third aspect would be the client, the person that you're working for, and that can be an internal client, or in our case, it's obviously an external client, and that is making sure that they have an understanding of the fact that AI is different from a normal IT project, and that it's very experimental. You might fail. There are lots of cycles and iteration, and that it's not a miracle cure. So you need a client who's educated, cooperative, and trusts you. So they trust you that if you say it can't be done this way, that's fine. And if you've wasted 2 or 3 days going down a route that turns out to be not fruitful, that is knowledge that you can plug into the next cycle, and that is not knowledge that's wasted. And you also need a client, internal or external, who's empowered to make decisions and to make investments and to take a bit of a risk, because some of this is encroaching on unknown territory. So the problem, define it, the data, get access to it, and the client work together and make sure that they understand what they're letting themselves in for when they try to throw AI at a business problem, is what I'd say.
Great, thanks a lot. Galina, would you like to add something?
I think that was very well stated. I would probably say also, we've done a little bit of work looking at maturity of companies, and we found that it's different types of projects, AI projects also, that are useful at different stages of maturity. So, if people are just starting out, it's important to teach them and set expectations, and it's more important to do something with data than to do AI, is my view of this, or to pick something that is really easy, and they have data for, exactly as was mentioned. And I would say it is at the later stages, it's when they operationalized a couple of more straightforward use cases, then you can really start talking about something that can be game-changing, that could be part of new business model and stuff like this. So I think a lot of the people are jumping to the later stage, and they're wondering how they can change their business with AI. I've never unless you're a startup, I've never seen people successfully jump on that end, but I've seen people spend a lot of money, trying to start on that end. So, taking the steps and working through stuff, I think, is important. And that's it from my end. Sorry, we don't have a visual on this, so.
Yeah, sorry, no, thanks. I think it's interesting because both of you are sort of talking about also acknowledging the importance of tidying up the bottom half of the pyramid we showed before in the hierarchy of needs. and the importance of having data available and knowing which problems it's relevant for.
And just to that, I would like to say that it is a bit of a chicken and an egg problem, because a few years ago, as most of you know, there was a lot of talk about big data and how big data is going to do things, and big data is going to be this and big data is going to be that. And a lot of people created their data lakes and they haven't looked. You kind of have to do a little bit of both at the same time. You know, you have to have some applications in mind as you're building out the bottom.
Mm.
I would add, completely agree. In fact, in our world, we have two distinct disciplines, data engineering and data science. And the data engineers are the people who understand databases, they understand APIs, they understand connections, and they understand how to surface data, if you like. They understand data lake technology, data warehouse technology. And that's almost a different, there is overlap, but that's almost a different discipline in ADL where I work, in that you have data engineers who are all about surfacing the data, and then the data scientists who are all about making use of the data. And some people are generalists, but there really is a demarcation between the two roles. And there's a very clear demarcation on the hierarchy of needs as well, which I was unable to present because I think I pressed the button twice, and I had a slide which maps the hierarchy of needs to data engineering versus data science.
Thanks. Maybe we skip to the next question. What would you say differentiate an AI project from other digital initiatives? Thanks for really interesting speeches. Maybe Galina, would you like to start off with this one?
Sure. Yeah, I think the word digital initiatives means a lot of things, because digital initiatives can be just something that looks at better collaboration software and you know, and how things are run, and you know, or it could be something that that actually starts looking at automation, you know, maybe without application of AI. So I think it gets back to something that Oliver said before, that I think there is a bit more risk that exists with some of the AI initiatives, and they start in a different space because they need data, and they need a lot of the times a lot of the built up at the beginning, even though it can be in some cases a simple built up. You know, people need to be aware that whatever they do now will be amortized over time. And people who deal more with digital initiatives, they tend to be very ROI focused. So they want ROI at whatever gets produced right now. And also they do projects, they think there's a start, the middle, and the end. Whereas an AI project, you do a start, you create something, and it has a model. And at that point, after you launch it, it's not the end. It's when you start improving things. And this improvement cycle is actually very, very important. And it's very important to bake it into the understanding, and it's important to bake it into the management expectation, or in case of a consulting company, I guess, into the customer expectations. What do you think, Oliver?
I 100% agree. I'm very pleased to report it's exactly what we find. You're talking about digital initiatives that, you're right, have a beginning, middle, and end. They have milestones, they have a project charter, and they have ways of managing that project, and they have budget management, and they have a high degree of predictability in many cases. AI has a lower degree of predictability, and that makes them more exciting in one way, but it does make them more risky in the fact that you could fail. And in fact, it's not so much a project as a set of experiments. There's a more scientific edge to an AI project. There's a more forensic edge to an AI project. And I liken it to a criminal investigation where you have the usual suspects on the wall, which are the usual data sources or the usual AI techniques, and you knock them off one by one sometimes, and you are allowed to fail, and you're allowed to do an experiment which doesn't work. And the crucial thing that Galina said, absolutely spot on, I think, is the sort of incremental building nature. You never really get to the end. You always improve. You always have better data. You always have better models. You always have better techniques. And I think the other thing that you said, Galina, is spot on as well, is that you need to communicate to the management or client that this is what you're letting yourself in for. It's not a completely predictable thing. The value will come incrementally. You will fail, and you should be allowed to fail. it's a cyclic thing. It's a scientific discovery. It's a criminal investigation, and you'll finally get the guy who did the crime, or you'll finally get the answer to what you're looking for. The other thing I might add to that, actually, and this is what we find a lot of the times, is because it's an experiment, you often find a really good result under laboratory conditions. So when you have a clean set of data, when you are able to get the correct currency of data, so that it's not too aged, and under those laboratory conditions, it works very well. Where you can fall down is when you try to industrialize the process. So if you're trying to do something that is predictive or optimizing, you need current data. So you need a system where IT can provide you with that data on a regular basis. It might be daily, it might be hourly, it might be real time. And you have got to start thinking, as soon as you start getting good results, how are we going to industrialize this? How are we going to make this work in the real world when the transactional data source is constantly being updated because the business is still running? We need to get hold of that data immediately. We need to make sure that the cloud computing power that we've instantiated is going to be enough to cope with the volumes that are going through it and to cope with the level of change. So I think it's a completely different type of project in the sense that it's a forensic experiment. It's fail fast and move on. It's like Galina says, build on what you already know to get a better result. And it's also, how do we industrialize this? And this is particularly true in business, of course. How do we move this out of the lab and theory into the real world with all the real-time volume, real-world complexities that are involved? And it's quite profound. And it's quite a profound problem that we've had in that people who don't understand the process of making use of data and gaining value from data using these new AI techniques do not understand how to sell it and try to commoditize it and try to say, we guarantee you that in 10 weeks, we'll create this much value for you. And that simply doesn't work. And it's part of the education of my colleagues and partly the education of clients as well, which will help us through this.
And I would like to add to it, and it's just from pain and suffering being actually in operational roles rather than in consulting roles. So when you run an data analytics or AI team and you talk about how long it will take to develop and what it would take, and then you have somebody come in with beautiful marketing slides saying that they already have this amazing thing and it's beautiful and it will give you this extra 15% of something. Go and talk for a long time to your teams, I would say, and also don't trust anything like this that you see on the slides, and and it has to do with AI projects. And so I think there's a very important questions for all businesses about what they should outsource to third-party companies and who should their partners be, and what they should build in-house and take the pain and suffering and also the OPEX instead of the CAPEX costs, I would say. But again, that's like another 1 hour of discussion right there, probably.
Let's keep that 1 hour. But
let's do that. Yes,
it's a good sneak peek. The next question is: many firms have a very fragmented data landscape with numerous data lake or data pools spread on systems. What are the first steps towards a data-driven company? Oliver, your turn to start.
Oh, right. So that's interesting. So I'm working on a data strategy for a company at the moment, and they're sort of arm's length governmental organization in the Middle East. And we hear this a lot, and I'm interested to hear if Galina hears this a lot. I bet she does, which is, right, we want to digitize. We want to be a digital company. And I'm saying, is your business digital? Well, no, our business is actually it's actually moving forms and making sure people's applications go through quickly and making sure they adhere to the rules of their licensing that we give them. So, okay, that's right. But we need to be digitized, and we have money to invest. And we're like, well, that's a good sign. We're quite pleased to hear that last bit. But you really need to take some time to understand what digitization means, and you really need to take some time to understand what making use of AI is. And we always start with the pain and gain and the use cases that are really valuable. So we ask searching questions such as, what would you like to know about your business or about your customer or about the person you serve that you don't currently know today? And if you start from the use case perspective, you can unpick the use case to work out what the possibilities are with regard to the data sources they have available to them. So every organization has a myriad of data sources open to them, and then they have open APIs to the outside world to make use of data that's available on the internet and elsewhere. But if you start from the use case, what would you like to know about the way your business runs? And what would you really like to know about the way your customer behaves and how your products, if it's a product-based company, work? And if you work from that basis, you can then start to unpick what are the data sources that are available to you internally to your business and externally that are unique, that make you unique and that no one else has access to. And once you start to unpick that, you start to create a data strategy which is use case driven. And what does that mean? The technology exists today. Mostly it's branded, and I really like the way that Galina says, don't trust the PowerPoint. As someone who produces PowerPoint, I completely agree with her. But data lake technology can allow you to be use case driven. So what does that mean? It means you create what is trendily now known as an MVP or an MVS, a minimal viable product or minimal viable solution, to give it a broader context. And what that means is you can create a data lake which is small enough to solve a valuable use case. And given the technology and the advances these days in data lake technology, you can build on that. So it's not like the old days in the mid-90s where to build a data warehouse took a year, 2 years, and I know because I built one for the National Health Service in the UK, admittedly a gigantic data warehouse. And you had to design every last feature of the data warehouse, every table, every link, every master data table, every transactional table, every piece of ETL, which was controlling the quality assurance of the data warehouse, etc. And by the time you'd finished creating your data warehouse, you had 700 different questions that you would like to ask of the data warehouse, and that the data warehouse wasn't designed to answer. So technology these days allows you to be use case driven. So you build your data strategy, possibly on data lake, but it depends what the use case is, but you build it by the use case and you derive value quickly to prove that there is value in your data and to prove that it is worth having a digital data strategy, which it is for 99% of the companies. So in summary, I suppose I'd say use case driven, understand what it is you'd like to know about your customer, your business, the outside world, and then look at the unique data sets you have access to, both internally and externally, to design the first, your data lake version 0.1. And your version 0.1 has to be workable, has to be scalable, and you have to be able to build on it, but it crucially has to deliver value early on the use cases that you define as those more valuable. And I mean, I would say this as a consultant, but this is when an external pair of eyes can be helpful in order to A, being rigorous about the questions you ask, and B, bring experience of where similar use cases have been successful. So yeah, those two things really, use case driven and incremental.
Galina, do you have any comments as well?
No, I think that's a good answer. So the only one thing I would like to add is that what Oliver said, and I used to give people as an advice, is to start with 2 use cases. And there's a practical, this is kind of a software engineering approach, you could say. The practical reason for it is if you start with 2 simple use cases, you develop something slightly more general than you would otherwise. Because a lot of the times, otherwise, if you start with 1 use case, you end up to over-designing or over-optimizing for it a little bit. So sometimes it's good to like have 2 things in mind, and then you may end up with a better system from which you will be able to produce more insights or create more little machine learning applications and stuff like this. So just a little practical thing.
Great. Start with use cases then. Next question is, what in your opinion are major risks of relying on AI in business? Thanks. Galina, would you want to start off?
I can start off. There are many ways to look at it, I think. I would probably say that there are 2 that jump to my tired mind right now. One is that if people don't think, if you remember what Oliver said about how AI is developed and that it's a bit of a stepwise process that you need to dig around, and if you're not ready for this, you may end up, spending more of the budget than you expected and not getting the results you expected. You kind of you really need to have the right expectations when you try to have AI in your business. And the second one I would say is that at this point, there's a lot more talk about responsible AI and AI ethics. I think the AI applications that we have right now, they're significantly more involved in people's lives and much more important than they used to be. And so it is very essential to evaluate AI that you have and to think about exactly how it's going to affect the people that work with us and also your customers, I would say. And there are too many examples to list over here, but I guess the one again that jumps to my mind, to my memory, is Babylon Health, a big AI health company in UK, developed a chatbot which did this nice classic thing of to women who came to it and listed heart attack symptoms, it suggested that they're suffering from anxiety. But if you were a man and you were suggested the same symptoms, it did think you were having a heart attack. Like, for example, if you're developing AI for medical applications, you may not think it's a big deal. You try it a little bit and see what happens. You try and you see what happens. But, you need to be looking at it more closely and thinking how it affects different populations and stuff like this. So, again, a lot can be said about this, but it's very, very important. Oliver?
Yeah, I agree. I mean, the simple fact of the matter is it might not work. And the level of predictability is lower than in many technology-based projects that you might put money into. And also, the other thing about AI is that I'm learning is that it's often not as deterministic as you might imagine. And what that means is that when AI goes wrong, it goes spectacularly wrong. In other words, if something is identified as a cat, that doesn't mean that something that looks roughly like a cat is going to be identified as nearly a cat. It's going to be identified as something completely different, which we don't understand because we don't understand the inner workings of the neural network. And that means these machines don't really think like us. They're black and white, they're binary. They categorize something as something or something else. Yes, they have a degree of competence, but the way that they get to that conclusion is different from the way that we do because we use our experience. If we see something with a back to it, 4 legs to it, a flat bit, and it's roughly the size of a human, we know that that's a chair. That's not the way that a neural network determines what a chair is. It has chair-like characteristics built within the weightings and biases in the network that it uses to determine whether something's a chair. So we don't really know how it works, and that's a risk because when it goes wrong, it goes spectacularly wrong. And in a car, instead of an autonomous car, might not just turn 1 degree too many to the left. It might do something completely catastrophic, like going to reverse. And then that brings all sorts of moral questions to the fore, of course, which is whose fault is it? Is it the fault of the person who created the model? Is it the fault of the person who created the data set, which was clearly deficient in representing the real world? Is it the car manufacturer? Is it the driver who put it on autonomous? And you can just see the lawyers licking their lips at the chance of making fabulous amounts of money in determining culpability when something goes awfully wrong. Is it the person who signed off the AI? So is it someone in the business, et cetera, et cetera, et cetera? You can understand the point I'm making is that not only is the risk of something catastrophic happening because these models are not infallible, nothing is, because the data that's been put through them to train them is not infallible, but also the culpability of of what happens if something awful goes wrong. And by the way, if something awful will go wrong, I mean that's absolutely that's absolutely something that's definitely bound to happen, and it'll be laid at the door of AI. I imagine autonomous cars will come in our lifetime, maybe not my lifetime, but maybe Galina's lifetime, and they will kill people for sure, 100%. People will die as a result of an autonomous car. That's absolutely inevitable. It's going to happen. In fact, it's claimed to have already happened, of course.
Yes, there's a famous example of an Uber car that has been test driving in Arizona that killed a woman, and I think they're still trying to unpickle that one for what it's worth.
Yeah, exactly. Yes, no, that's right. I remember that. Thank you. And so, I mean, what is going to happen is they're probably going to save lives. They're probably going to save hundreds of lives, thousands of lives. Like 750,000 people die on the roads in the world every year. They will save thousands of lives, but the newspapers will point to the car that killed the person. The cuter the person, the better the headline. So there will be cock-ups. And there will be people held accountable, and that will be incredibly complicated. The other thing is, I worked in the defense industry, and they were worried about hacking. And of course, as soon as you rely on computers, you open yourself up to a whole new world of these so-called black hat hackers. In other words, the naughty hackers, rather than the white hat hackers, who are the nice hackers. And that becomes actually quite scary, because you could put all sorts of pieces of sleeper code into these algorithms, which can awake at some point and cause all sorts of catastrophic results. So I love computers, I love maths. I'm very excited when we find a use for technology, particularly AI, but we must, we rush into these AI solutions at our peril, because they're incredibly powerful. And as soon as we start relying on them very heavily, the further removed from reality we are. It's another layer of abstraction on the real world, if you like. The computer says no is a phenomenon which is bad enough, but when the AI algorithm says no, we start to get into a Stanley Kubrick situation where we're being ruled by the computers. I'm an optimist. I don't think this will happen, but if we go in without that level of caution and really understanding the power of these machines, then we could be in for a rough ride.
And I would probably say that as an American citizen, that the major risk for AI, over AI right now, is democracy. You know, as can be seen with what's happening with Facebook and the rest of those. And, you know, that's a pretty important one. But yes, I think the big question also, and Oliver probably has experience with this in terms of AI risks, is a lot of the times the first question is, not the first question, but one of the questions to ask is whether you need AI in a particular situation. Like, I've read a study which said that 60% of people said that they would prefer an AI manager over a human manager. And this made me wonder if we shouldn't be training our human managers better rather than developing an AI manager. So, but all kinds of things, all kinds of interesting things over there.
I completely agree with that on the management front. Interesting.
I agree too. Maybe a combination. We'll try to cover as many questions as possible. We have 6 minutes left, so maybe we can have some shorter answers to the coming questions. The next is, to what extent is AI automating simple repetitive manual tasks doing better and faster, so more RPA-like, and or intelligent, finding new insights that humans otherwise wouldn't?
I think we've got a convention here, haven't we, Ingrid, that you tell us when to talk, and I think that's been very helpful.
Sorry, please continue, Oliver.
Oh, me? Oh, right. I was hoping you were going to say Galina. No, I'm going to give a short answer here. I think it's more the latter. Yeah, I think it's more the latter. It's using data to get insights that humans wouldn't. And the funny thing about Galina's observation about the manager is, I think the machine is unlikely to get insights that the human wouldn't in management, because management, in my view, is not telling people what to do, but it's motivating people to contribute the most and get the most out of their job. A machine at this level doesn't have the intuition. I don't think it will ever develop the intuition to understand people's emotion and to understand what makes them tick, and to have compassion, which is one of the largest parts of management, in my view. So I think less about the automation, but more insights that humans can't see. And the insights that humans can't see are generally patterns in very large amounts of tabulated often data, which we simply don't have the brain capacity. But what we do better than machines will ever do is that intuition, that compassion, and that thing that makes us uniquely human. I don't think that can be replicated by machine.
I think that's a good point. I think that the first description, automating simple repetitive manual tasks, sounds not a lot like machine learning, but a lot like, for example, robotic process automation.
Oh,
And
definitely,
we're
yeah.
looking at your definitions earlier with the bubbles. Machine learning is where you learn from data, and as you said, we're talking about data that is vastly beyond what we humans can process. And then, of course, not all use cases would be relevant for this application, but when we're talking AI and AI use cases, that is normally what we're talking about.
I would like to just one quick thing. So Andrew Ng, I think, was asked about what machine learning can do well these days. And I think his view was, if a human can do it, most of the things, not all of the things, so this gets back to certain other stuff, but if a human can do it in 5 seconds, that's likely something AI can do today. So for example, recognize a face, or do something quickly like scan a receipt and determine that here's a number that was a total or something like this. And it's not a foolproof thing, but humans can do a lot of complicated things. But the things that we can do very quickly, they tend to be kind of very automatic. And I think for a lot of them, we have good machine learning methods these days where we can try to figure out how they can be applied. Anyway, just another 2 cents, quickly.
And there, I guess this is the last question, but great talk, Galina. How do the two digital AI journeys, optimizing internal processes versus optimizing products, intervene? Can they be parallel?
I would say that everything that you saw on the diagram can be parallel one way or another. We find that depending on the company, you may do things in different ways, and it also depends on your existing capabilities and your existing resources. Also, it may be the case that for some people will optimize internal processes and do internal things with third-party machine learning applications or APIs, and sometimes they will develop their own. And if they develop their own, then the same data will probably be used to also to create their AI products and features in the other place. So a lot of the times you really want to have fewer data sets that you can use for multiple purposes. What's a good example? So if you're any financial company, your 2 first key applications, you could say, are around optimizing internal processes, and they are fraud detection and credit evaluation. So you can think of that same data and some of the same things being available to the users as some kind of a feature or product, or being used in features or products. But at the same time, these 2 things are really, to optimize the internal operations. So these types of things can be really close or can be quite far apart. So I'm sorry, not a good answer perhaps, but it depends, I think. There's nuance in all of this.
It depends is normally a safe and good answer. Perfect. I think that we will need to stop here. We're at 7:59, so I think another question will be a bit.
I with apologies, Ingrid, if I may. So there was some person who said that they were in economics, and my note to them is, get a book called Prediction Machines first and read it.
Oh, awesome. Prediction Machines.
And that was a quick answer.
If I'm allowed a book, mine is The Signal and the Noise. I'm sure you've heard of it, Galina. Probably read it.
Yeah, I've heard about it, but didn't read it. I think it was more so Prediction Machines is basically written by economists who are thinking about how to think about AI, and their point is that AI is basically about predictions and cheap predictions. So that's, I think, a good place to start for anybody who has kind of more economics background. And of course, and also there are no formulas.
No, signal and the noise is more. Yeah, that's right. It's more trying to understand what is significant in the myriad of data that is available to us. The signal and the noise. It's written by a prodigious, talented young man who predicted. I think he predicted at a very young age most of the states in a presidential election. And
that's Nate Silver, wasn't it? Who wrote it?
That's the man. Yes, yeah. Exactly. Nate Silver. That's right. So yeah, that's right. He was a sort of protege.
Yeah, I think he's extremely well known in the United States, but not so much around here, I find.
Yeah, I don't know how I got hold of that book, but it was a page turner. If a book about numbers can be a page turner, it's not everybody's cup of tea, but maybe some people on the audience here.
Maybe some people who'd like to move into data science.
Yeah.
We will need to cut it off here. We're already past the hour. But thank you so much, both of you. I will also send out a short survey to everyone who joined, just to be able to, first of all, get some feedback, but also some ideas for what you would be interested in hearing when we are hosting the vertical specific or the industrial focused events for AI in business. So thank you so much, both of you. This has been super interesting and fruitful.
Thank you very much for organizing, Ingrid.
Yeah, and thank you for the invite. Always very pleased to have this kind of thing. Really enjoyable. Thank you, and great to meet you, Galina, as well.
Same.
Thank you all, and good night, I guess.